In this video, we will learn multiplication properties of exponents. To simplify an exponential expression, number one, you need to get rid of any negative exponents as previously discussed. Secondly, we need to simplify our powers using the multiplication and division properties. In this video, we will only be talking about some of the multiplication properties. First, take a moment to rewrite this expression 3 to the second power times 3 to the third power in its expanded form. That would look like this: 3 times 3 times 3 times 3 times 3. If we rewrite that in exponential form, that would read 3 to the fifth power. For the second example, y to the third times y would expand as y times y times y times y. In exponential form, that would be y to the fourth power. If you notice, starting at the original expression, 3 to the second power times 3 to the third power yields 1, 2, 3, 4, 5 threes for our answer of 3 to the fifth power. We could simply add our two powers together to get our new power to combine the exponents that have, as long as they have the same base number or variable. Keeping in mind for the second one that y has a power of 1, so 3 plus 1 equals 4. That saves us the time of expanding that all the way out and gives us a little shortcut to get to our answer. That brings us to our first property, the product of powers. For every non-zero number a in integers m and n, a to the m power times a to the n power equals a to the m plus n power. Noticing, of course, that that base has to remain the same all the way through. Let's take a look at a few examples. These ones are not in your notes, just as some simple ones to start. 10 to the third times 10 to the sixth would be 10 to the ninth power. Notice we don't multiply 10 times 10 and make that 100 because there are 9 tens, not 9 100s. This next example, m to the negative second times m to the sixth would be m to the fourth because negative 2 plus 6 equals 4. For this example down here below, 4 times x to the seventh times x to the first would be 4 times x to the eighth. And for this last example, we have 5t to the third times 3t to the fourth. This would give a result of 15. So 5 times 3, we can actually multiply those together and put one coefficient at the front. And then t to the third times t to the fourth is t to the seventh for a final answer of 15t to the seventh. Now that we've tried those simpler examples, let's try a few more difficult examples. If you would like, these ones are in your notes to write down. For our first example, 2 times 3 is 6, so we can write that in the front as a coefficient. B to the fifth times b to the negative second would be 5 plus negative 2, which is b to the third power. For our second example, we can bring 4 times 7 to the front as 28. And then we have m to the second times m to the first, which makes m to the third. And then we have an n to the first and times n to the negative second, which makes n to the negative first. Now, if we recall from yesterday, an expression is not in simplest form if there are any negative exponents. So we would not want to leave our answer like this. Instead, we would want to take that n to the negative first and move it to the denominator for it to be a positive 1, leaving our final answer as 28m to the third over n to the first, or just n. A human body contains about 3.2 times 10 to the fourth microliters of blood for each pound of body weight. Each microliter of blood contains about 5 times 10 to the sixth red blood cells. Find the approximate number of red blood cells in the body of a 125-pound person. Write your answer in scientific notation and try to do this without a calculator. Since the person is 125 pounds, and there are this many microliters of blood per pound, we're going to multiply this times this. And then for the number of red blood cells per microliter, we're going to also multiply by that. When we do this on a calculator, you can type in the entire problem and get the answer right away. I want you to see how it works by doing it on paper though as well. So when we do multiplication with scientific notation, the actual numbers that we're going to multiply together are these numbers. So 125 times 3.2 times 5, which is 2,000. And then we have 10 to the fourth times 10 to the sixth. This is an entirely multiplication problem. So 10 to the fourth times 10 to the sixth would make 10 to the 10th. But this 2,000 times 10 to the 10th is not in scientific notation. So we need to take our decimal and scooch it back over 3 spaces, which would make our final answer 2 times 10 to the 13th red blood cells. Now let's take a look at another rule that we are going to use for exponents. If you take 2 to the third power and you raise that to the fourth power, that would look like an expanded form, 2 times 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 2. 2 to the third 4 times for a total of 12 2's. That's 2 to the 12th power. For our second example, if we do x to the fourth power, that's x times x times x times x to the second power for a total of x to the 8th power. How do you notice that we can skip this expanded form step, which takes some time, and go straight from our expression to our answer? Well, we can multiply our powers, 3 times 4 to get 12, and 4 times 2 to get 8. Noticing that this is a different problem than our last rule. So in our previous example, we had 2 to the third times 2 to the fourth. That was equal to 2 to the 7th. This is 2 to the third power, that 4 times. So that's 2 to the 12th power. Just to notice the difference between the two is important. That brings us to our power of a power rule, which says that for every non-zero number a, in integers m and n, a to the m power raised to the n power is equal to a to the m times n power. Let's take a look at a couple simple examples before we try the harder ones in your notes. 4 to the third power raised to the second power would be 4 to the sixth power. X to the sixth power raised to the negative third power would be x to the negative 18th power, or 1 over x to the 18th power with a positive power. Now let's try the harder ones that are in your notes. For this first example, we would start by doing this part of the problem first, because the order of operations tell us to do exponents first before multiplication. So if this is multiplication, this is an exponent. So c to the third raised to the negative second is going to be c to the negative sixth power. Now we have c to the fifth times c to the negative sixth, which would be c to the negative first, or 1 over c is how we like to write it so that there are no negative powers. Our second example, a to the 4th squared would be a to the 8th times a squared to the 5th power would be a to the 10th, and then a to the 8th times a to the 10th would be a to the 18th power.